This is section 5.5, trigonometric equations. What we've been doing up until this point has been verifying trig identities. And identities are supposed to be true for all values in the domain of the variable. And generally what we did is we started off with one side of an identity and we transformed it into the other side, showing that no matter what, the left-hand side is always equal to the right-hand side. Now, when it comes to solving trig equations, that's not necessarily going to be the case. Usually, an equation has some solutions, but not everything is a solution, okay? So it is possible for a trig equation to have no solutions at all. It is theoretically possible for it to be an identity. But for most of our problems, what we're going to be doing is we're going to be trying to find the angles that make the equation true. Okay? And we're usually going to have more than one solution. And that's because since trig functions are periodic, if you find one solution, then you either add 2 pi to it or 360 degrees, depending on whether you're in radians or degrees, and you've got another solution that will work. So we're often going to have to find a way to indicate all of the solutions, and then other times you're going to be asked to give all the solutions in a particular domain. So they may ask for all solutions between 0 and 2 pi, or if you're in degrees, between 0 degrees and 360 degrees. Okay? Now, basically, we have to remember this kind of stuff. If you can get sine of something equal to sine of something else. One thing we know is that your two arguments, your x, can equal alpha here. And then you can go all the way around the unit circle again and again and get more solutions. So if I have sine x equal to sine alpha, then my x solutions are alpha, whatever this is, plus however many times around the unit circle we want to go. But we also have some other possibilities. And the other set of possibilities you would get from doing pi minus that alpha variable and then adding 2 pi to go around. And that's because, you know, if you have two quadrants that will give you the same value for sine. You have two quadrants that will give you the same value for cosine as well. And so we have to, this will be the adjustment to get us into that other set of solutions. For sine, you're going to add, it's periodic with 2 pi. So you're going to be adding 2 times n pi. This just, an n is an integer, just telling you like how many times you're going to go around the unit circle, however many times you need to. And for sine, you could also take that alpha and subtract it from pi. Cosine is very similar. It is periodic with 2 pi as your period, so adding 2n pi every time to get to your extra solutions. But because of the difference in what quadrants give the same answers for cosine, to get your second set of possibilities, you're going to subtract from 2 pi instead of just pi. Now, tangent is different. It is periodic. Its period is pi, so you're not adding 2n pi every time. You're just adding pi every time. And you only really have one set of possibilities. You don't have to worry about getting two possibilities within the unit circle. Okay, so this is your basic chart. It's going to help you get to your solutions. And I've written it with 2n pi, but if you're dealing with degrees, if you're going to add 360 degrees n instead of 2n pi, or 180 degrees n for n pi. Okay? Now, our basic steps is we're going to find an angle that satisfies the equation, okay? And we do that by finding inverse trig functions. And then once we have one solution, then we use what we have over here to generate the rest of our solutions, okay? So let's start off with sine of x is equal to square root 3 over 2. We are asked to find all the solutions, and we're supposed to give our answer in radians. okay? The first thing we want to do is we want to find one solution. And what we can do is to find inverse sine of the square root of 3 over 2. And that will give me one angle that has sine of that angle being square root 3 over 2. And so if you find inverse sine here, you get pi over 3. Okay, so what this tells me is that sine of x is equal to sine of pi over 3. That tells me that I can use pi over 3 as my alpha variable. Since this is sine, one set of possibilities is your alpha plus 2n pi. So x is equal to pi over 3 plus 2n pi. That's going to give me infinite number of solutions, just going around the unit circle however many times as I need to. Everything that is coterminal with pi over 3 is a solution. Now let's find the other set. So we do pi minus our alpha. Plus 2n pi. So our other set of possibilities would be 2 pi over 3 plus 2n pi. So all of the possible solutions to this equation are either of the form pi over 3 plus 2n pi, so coterminal with pi over 3, or they are coterminal with 2 pi over 3. Okay, let's solve tangent of x is equal to negative square root 3 over 3. Well, the first thing we do is we find tangent inverse of negative square root 3 over 3, and that's going to give us an angle that will work. Inverse tangent of negative square root 3 over 3 is equal to negative pi over 6. So negative pi over 6 is my alpha. I know that tangent of x is equal to tangent of negative pi over 6. Now to find our solutions, when we are dealing with tangent, it is alpha plus n pi. So all of our answers are negative pi over 6 plus n pi. That's every single possible solution to that equation. All right, now let's do cosine of x is equal to negative 1/2. So the first thing we do is we find inverse cosine of, negative 1/2. And inverse cosine of negative 1/2 is 2 pi over 3. So 2 pi over 3 is my alpha. One set of solutions for cosine is alpha plus 2n pi. So 2 pi over 3 plus 2n pi. Or our second set of possibilities, we subtract it from 2 pi, we subtract our alpha from 2 pi, and then add 2n pi. So 2 pi minus 2 pi over 3 plus 2n pi, which x is equal to, that ends up being 4 pi over 3 plus 2n